Just want to make sure everybody got this last answer down. I know we said it before the video ran out, but I didn't know if everybody got it. So after 60 months, because I brought my labels down, X is number of months, Y axis is dollars, the loan will be paid in full or paid off or something to that effect. Okay, let's go ahead and move to page 3. Well, my marker leaks through a little bit, so ignore those little dots. That was from our last graph. Sorry about that. The graph below shows the number of calories burned while riding a stationary bike. We had this one on the test last semester, so if I can find one like this in Alex, I will do that too. So we have number of calories burned on the y-axis and time in minutes on the x-axis. So it wants to know the input variable, and we know input, remember, is x. So the x-axis is time in minutes. And the output variable we know is y. Y is number of calories burned. Determine the rate of change. Easy schmeezy. We know all this from chapter 6, huh? So rate of change, and they gave us the 2 points. And don't forget, we do need to have our y per x at the end. So we'll write it over here to remind us. Excuse me. Second y minus first y would be 80 minus 40 over second x minus first x, 20 minus 10. So this is 40 over 10, which is 4. Now we need to know for what. So y per x would be calories per minute. I guess calories burned per minute would be better. And you can see why we need to label slope, because always the next question is write a sentence about it. Well, if you just do for and walk away from the problem, you're going to go for what? So that's why I always write that. I mean, I know it in my head, but I write it anyway just to help me with the order. So calories burned per minute. Okay, what's the practical meaning? Well, they're on a stationary bike. So while riding a stationary bike, 4 calories are burned per minute. While riding a stationary bike, four calories will be burned per minute. While riding a stationary bike, 4 calories will be burned per minute. Sounds good to me. Create a linear function C. Remember, the minute you see that, you write this. Linear function, linear equation, write an equation, boom. That's what you're going to write. Anytime it's a line, we write y equals mx plus b. So we can see our C is going to be our y. It's capitalized, and our m is going to be our x. They do want it in function notation. So that tells me in place of y, I'm going to write C with respect to m. That's just telling the reader we're using C for y, and M is our X, because X is always what's inside parentheses. Slope. What is the slope? Oh, there it is. Remember, rate of change is slope. So, and it's positive. So positive 4. What are we using in place of X? Look in your parentheses, M. Don't get that mixed up with slope. M doesn't mean slope in this problem. Plus, B, remember, is the y-intercept, the y-coordinate. So look at your table, and where does it cross the y-axis? Oh, it crosses the y-axis at 0. So C of M, or C with respect to M, is 4M plus 0, because our y-intercept, where the graph crosses, I can't get them both on the graph hardly, but where the graph crosses the y and x-axis, so on this graph the y-intercept is 0, 0, and the x-intercept is 0, 0. That's the only place it crosses the y or x-axis. What is the vertical intercept? Like we said, it crosses at 0, so that would be 0, 0, because remember, vertical intercept means make x 0, because it's the y-intercept. So I made x 0, and then I looked on the graph and saw it was 0. What's the practical meaning? Remember how we put our labels here? So our x in this problem is time in minutes, so let's do minutes. And our y is calories burned. So always label your point before you write your equation. So what does it mean? When I have spent 0 minutes on the bike, I will have burned 0 calories. When I have spent 0 minutes on the bike, comma, I will have burned 0 calories, which is not true. If this person's chewing gum, I heard chewing gum burns calories. No. So when I have spent 0 minutes on the bike, I will have burned 0 calories. There we go. So just like what we've been doing all along, you write a point, label what the X and Y are, then the sentence just falls into your lap. If you exercise on this bike for 40 minutes, how many calories will be burned? Well, if you look at the graph, 40 minutes isn't on the graph. So that means plan B is use the equation. So here's my equation. C of M equals 4M plus 0. And remember from up here, they wanted us to call this, let's see, M is the number of minutes. So this they are calling M. And C is the number of calories burned. So they called that C. So if they're giving us 40, are we going to put it in place of calories, or are we going to put it in place of minutes? Of course, we're going to put it in place of minutes, right? Because they don't always give you the X. Sometimes they'll give you the Y, so you have to look at the labels. M is minutes, C is calories, so I'm putting 40 in place of M. So C of 40 equals 4 times 40 plus 0. So we can easily see C of 40 is 160. So if you're on the bike for 40 minutes, you will burn 160 calories. you will burn 160 calories. These are pretty fun, aren't they? This is what our final's full of, is problems like this. I love these problems. You will... Oh, Kim, quit talking while you're writing. If you're on the bike for 40 minutes, you will burn, not be, 160 calories. Yeah, I'm definitely not a multitasker. Can't talk and write. So that was easy, right? Yay! Okay, so we got about 5 minutes, 4.5 minutes. So we'll go ahead and start the next page. Might take a couple videos. Probably won't be able to get done, but we'll at least start. So here's our function. It represents a computer manufacturer's profit. So P stands for profit. I like to let myself know these things. When N computers are sold. So N is the number of computers sold. So the more descriptive, the more things I write, the easier it makes the problem. Then I don't have to keep back going up and reading it. I have it all right there. And obviously the profit will be in dollars, so that's our label there. And then N is the number of computers sold. Name the input and output and what they represent. So input is always our X. So what are they using in place of X? Look inside parentheses. So N equals, and it says what they represent, the number of computers sold. And make sure your variable statements are very descriptive, because we are picky about that in this class. Very descriptive. Like I said, they have to contain a variable, what they stand for, and the units. Output is always our Y. Let's just put that out here just to remind ourselves from Module 6. So the output is the answer, the Y, and in this case our output is P equals, and that would be computer manufacturer's profit in dollars. Identify the slope. So Y equals mx plus b. So m is always a slope, so it is 425. And what does it mean? So 425 times the number of computers sold. Do you think this is their profit per computer? This will probably be like their expenses. They have to pay employees, pay electricity, pay rent. So this is probably their expenses because it's getting subtracted. But when it's multiplied by the number of computers, that means you get $425 per computer in profit. So each computer sold yields a profit of $425. Does that sound good? So each computer sold, let's use our increases, decreases. So each computer sold increases the profit by $425. So increases, because it's a positive slope, the profit by $425. And we'll start from there on the next video.